Thanks very much, Jacinta, and thanks for having me here today. So I'm just going to talk about saving time using implicit modelling in Studio ORM, and I'm going to use King of the Hills as a case study. I suppose just a few disclaimers. Hang on, I just need to try and, there we go. So just a few disclaimers that I'm not an implicit modelling expert by any means, and I've only really started using that in the last few months, I suppose. I have been following the implicit modelling functionality in DataMine for quite a few years, and I'm really excited to see where that's at presently. I suppose my previous or my current experience has been based using sectional strings. And I suppose I always revert back to using sectional strings for modelling because I like the level of control that I have over the output wireframe. And I suppose when I'm reviewing the implicit modelling function, I want to see as a user how much control I have over the output wireframe to make sure that it makes geological sense to the understanding of the deposit that I'm modelling. So any comments I make in this presentation, my opinions. And I suppose the other important note is to comment that any, when we're looking at any modelling technique, we really need to have a level of geological knowledge of the project. And that's from modelling using the string method. So I'm hearing myself back a little bit, so I do apologise if I'm a little bit, yeah, I can just hear the microphone. But, so with any modelling technique, we need to have that level of geological knowledge. We can't go blindly in, pressing buttons and expecting we're going to get a representative result, because everything, and that's from using the string method through to implicit modelling, even using point cloud data to generate DTMs. So in this presentation, I aim to illustrate how we can use the new functionality in DataMine in Studio ORM and Studio ORM Pro to try and save time in generating wireframes for exploration, production and resource environments. And the saving time potential really allows us to spend time in understanding our geology initially, rather than spending time to generate the wireframe. So to be able to access the vein modelling function, there's no additional modules required, and it sits in the vein function. I've got that highlighted in the top right there. I've highlighted with the red box. And of particular importance, DataMine now gives users a greater control over the output shape, and I really wanted to explore that further than the previous versions of this function. And this is through the specific controls, or assigning specific controls using the customization tools. So I'm going to look at King of the Hills, which is a geologically complex project with a strike extent of over 2 kilometres. And therefore, reviewing alternative modelling techniques while ensuring representative models are generated has the potential to improve efficient timing of updates and estimations. And this is for resource estimations, but also for grade control estimations in the production environment. So for this study, I looked at 10 mineralised veins, which represents 75% of the overall vein volume of the project area. I haven't worried about looking at depletions in this study because I really wanted to have a look at how well the implicit modelling function can represent the geology of the project. And where we have depleted the resource, we have really strong information on spatial position of that vein. So I really wanted to see with the data we have how we can generate this implicit model, these wireframes through the implicit modelling. So these veins were previously modelled using the string method across 10-metre sections with an average strike extent of 430 metres. So when we look at updating these wireframes using that method with a handful of additional points, it becomes a timely exercise because it's not just the drill holes we need the strings to snap to, but we really need to have a look at our interpretation across section or along section and down dip to ensure that continuity exists within that wireframe. So after I generated these wireframes, I wanted to look at the comparisons with the existing data. So these are visual differences, but also volume difference, and then briefly looked at the percentage ounce difference, and then the time it took to complete these wireframes. So I think it's really important to make a comment on data quality. So before we even think about running the implicit modelling function, we really need the data to be coded and attributed properly for modelling. And I think this is the one process that requires the most control. And depending on the project's geology and mineralisation controls, whether that be visual and or analytical, some possible ways we can attribute data is to do that directly into the database during logging or through drill hole validations, and that's independent of the software, as in Studio RM. And typically we can use lithology or flag lithology or weathering profiles at this point. Now, if we're looking at assigning attributes in DataMine, we can easily do this by stepping through in section and plan, using the assign function. I've just got an image of that on the right of screen there. And again, I've just highlighted the function with the red box. And this is a really interactive tool that allows us to select or assign and unassign an attribute field. And it's really quick and easy to use. And it allows us to essentially generate a legend as we go. Now, for this study, I haven't looked at assigning data directly into in DataMine because we already have that data available. And I've actually coded that using, I call it cell wireframe, just for ease of speaking, but it's SELWF function, and it utilises the existing wireframe where it codes the drill data as it pierces the wireframe and exits the wireframe, and we get that drill hole that we can then code accordingly. Now, I think if we're looking at applying implicit modelling into a deposit that has existing wireframes, this would be a really quick function to be able to assign attributes to the drill holes. And then from there, we can use any subsequent drill data or code subsequent drill data. I think the other point to make here is that if you code in DataMine, to be able to use this time and time again, independent of the DataMine project itself. If we look at, there's a few ways we can manage data moving forward, but I think one way, which is a really neat process, is you can export that attribute field along with the hole ID and the from and to intervals and import that back into your database. And then your database not only becomes a storage for your analytical and metadata, it becomes this ability to store your modelling data as well. So you can have subsequent users utilising that data consecutively if they're, or simultaneously, I suppose, if you're looking at different areas of the mine. So you're not limited to the one project file. So moving on to the actual implicit modelling function, I wanted to see how much I could test this function, to be honest. I wanted to first see how much I needed or how little I needed to do, and then I wanted to see how much I could push the limits or whether I could break it. And DataMine's done a really fabulous job here in making this really user-friendly. So initially, I just selected the drill data, the attribute field, and the attribute. And the algorithm in the back does its thing and auto-populates fields for you. Now, on the right of screen there, we've got generates hanging wall footwall points. If anyone's interested, the red's hanging wall, green is footwall. And then I didn't do anything else, so I just pressed compute new. And this wireframe then is generated. Now, this wireframe is not the final wireframe. I suppose you can call it an interim wireframe. It really gives you an idea on what the trend of your domain is according to the data that you've got. And there's a few holes in there. The bottom left doesn't necessarily look geologically sound. And I have to say I was pleasantly surprised in how this vein turned out. And then all I wanted to do was overlay the existing wireframe, and this is what it looks like. And I suppose there's a few conclusions we can draw from that initially, that they're pretty much the same. There is some minor variability internally, but when we step through it, it's really not that much. And so now we can start playing around with this wireframe when we look at all our customization tools. So I'm going to talk about 4 here, and there's 3 on the other slide, but we can look at uncertainty, our section controls, even controls and boundaries. So uncertainty talks about or applies a level of confidence to your data points and whether you have confidence that that data sits there spatially. And so if you believe that that data is where it should be, you could leave your uncertainty at 0. Now, depending on what you're modelling, you might choose to change this, but you really have the ability to manage that yourself based on the knowledge you have of the project. So section controls looks at the trend of your interpretation. Now, we're really lucky here because we have a lot of data, but where you may not have a lot of data or as much data as this, you can set your trend based on the knowledge you have of the project. And you can set that trend by generating a plane using 2 points or 3 points or using the section editor tool. Now, the section editor tool allows you to, in 3 dimensions, to be able to drag the strike and rotate on dip based on what you visually see. And it is really user-friendly. And I've played around with that a little bit just to see the influence that it had on this wireframe. Because we've got a lot of data, you could see some minor changes on the extents, but I think it'd be really powerful in areas where you don't have as much data. The controls function's really cool. We can set a minimum thickness, a maximum thickness of the wireframe. We have expand to or remove below. And that depends whether you want the wireframe to expand to that minimum thickness. I think what is really important as well is if you're going to use a minimum thickness, you also need to make sure that your data that you're incorporating or attributed also is at that thickness. If it's any less than that, there'll be a volume issue when you move forward into estimation. You really need to think about the application of your wireframe, whether it's based on lithology or you're going to use it for mineral estimation. Resolutions, I think speaks for itself. It talks about the triangulations, high resolution, less angularity, it's a bit smoother. Low resolution, there's a bit more angularity. And the pinch out function is something that I've recently played with. And I think it might seem it's pretty straightforward for some, but I think if you are attributing your drill data and you've missed a hole and you haven't attributed it properly, if you have pinch out on as your wireframe is generated, there will be a hole in your wireframe where that drill hole, hasn't been attributed properly. And so then it will flag holes that may need you to either look at why it wasn't included. Is there an issue with your with the data? Is there an issue with your interpretation? But it really allows you to start to pull out internal factors within your interpretation. So the boundary function I really like, and the default is the alpha shape, and alpha shape allows you to set an extension distance and a segment length. These are automated for you. I have changed this to 10 in this example. I think it was at 29, 30 before, but it allows you to set the wireframe extension beyond your last data point. So if you want to only extend your wireframe half your drill spacing, you can do that. If you want it to be longer, you can. It really comes back to what your application of your wireframe is for. Segment length looks at your internal, what I believe to be your internal continuity of your data points. And so this is calculated for you. I have changed this to show as an example to 40, and it smooths the angularity at the bottom of that wireframe a little bit. And the process to update and make these changes, you can make one change, press recompute, make another change, press recompute, and it'll automatically update your wireframe. And I think that's really powerful to be able to make one change and review that change and see whether that change, what the implication of that change is. And you can start to really understand how these functions impact your geology and your wireframing, and then it allows you to make quick changes. In the boundary, you can still use a perimeter string if you choose to, and I think there's a square function which uses the extents of your wireframe on section and in RL. So additional points, I think self-explanatory. I've got a few pictures there, but the additional points, you can add in interpretive points to change how your wireframe looks. So I've added a few points there and done the recompute. I then changed the segment length to 45 to remove that triangle out. And so you can start playing around with these small functions to really start to improve that wireframe. Edit samples is probably something that I would spend the most time on. You can individually select each individual attributed drill hole, and you can decide whether you want to use it in your interpretation or not. You can turn it off. You can switch your hanging wall and footwall points around. In the image on the right there, the green, there's some hanging wall points there's some footwall points on the hanging wall, and vice versa. And so this would generate crossover faces in your wireframe and generate a volume issue. But you can select that independently and reverse them. So you have this level of control that is on a big scale that generates the overarching geometry. But you also have internal finer control. And I think DataOne's done a really neat job in understanding what people need in their estimation, in their wireframing to and they've listened to that, and it's become really user-friendly. So these wireframes took me all of 10 to 20 minutes to generate. And I think over the 10 wireframes, it's less than a morning. If I was generating these and updating them using the string method, I'd be there for a week or more, just to really finesse that continuity across section. So I really then wanted to take these wireframes and have a look at how they related to what we already had. And so the image on the right there shows the implicit wireframe in red and the string method wireframes in blue or aqua. And I think straight away you can see that there's some really similar trends. And this not only supported the interpretation at King of the Hills, but it also showed that there's an ability to generate robust interpretations using DataMine's implicit modelling functionality. And I think it's all about that confidence, making sure that as you code your drill data and have the knowledge of the deposit, and you want to try and replicate that in your wireframe, if you've coded that drill data properly, then your implicit modelling may be able to represent that quite well in comparison to the string method, which takes a lot of time. And so looking at the volume difference, I guess globally that was less than 5%. And there is a greater difference on a vein by vein scale. And I think some of these differences can be attributed to varying wireframe boundaries, whether we've changed the set extension distance or added additional interpretation points. And other factors may be your internal thickness, because we have set an internal thickness. But I really wanted to push this a little bit further and just have a look at the material difference in the resource estimation, just really briefly looking at it without actually looking at any changes to the estimation. So the percentage ounce difference was less than 5% as well. And I was only looking at the indicated and inferred material because that's where we had most of the data. And I think that 5% or less than 5% really can correlate back to that volume difference that we see. We could spend a bit more time further refining these implicit models to reduce those computed differences, but that wasn't the purpose of this exercise. I really wanted to see how well I could replicate the interpretations at a project that we had existing wireframes for and had a lot of data, which was quite complex. And I think from this, so we've started actually looking at applying this modelling technique with other projects based on geology, depending on the geology, based on the confidence that we have in this comparison study. I was really surprised. The implicit modelling prior to version 1.8 in StudioRM, I wouldn't have thought we could have generated wireframes like this. And I think having this match up so well really shows that you can spend time in your interpretation at the data level rather than worrying about how quick it's going to take to do the wireframing, because it took no time. And I suppose we can talk about the benefits with the wireframe, and I think I've covered that a little bit, well, mostly throughout the presentation, but this really allows the user to have control over the wireframe that they want to generate. I think the boundary function is really important and powerful, and being able to select your internal data and manage that appropriately, and then assign a orientation plane really makes it quite straightforward. And I think if you needed to look at it, adding additional drill data, you need to change your minimum mining widths based on looking at different mining methodologies, or you want to increase the extent of your wireframe to assist with drill targets, this could be done quite quickly. And the time associated with this is really based on attributing data. The wireframing time takes no time at all. And this function is not limited to modelling mineralised veins, but We can use this to model geology units, depending on the complexity. There's still some work going in to the categorical modelling, I believe, which may help with things like granites. But in terms of geology that may be somewhat linear and have a hanging wall and football point, like regolith surfaces, contacts or faults, you can model these with ease, I believe. And I think the limitation is really on the user and the understanding of the deposit, and being able to code your drill data properly and making sure you've got quality data. But no, I think DataMine's done a really wonderful job here, and I'm really looking forward to the future with using this function in future projects. So thanks very much.